Hi, everyone, and welcome back to Psych 3510 for our second half of the lecture on frequency of data and frequency tables. My setting is a little bit different today. Unfortunately, my house required a little bit of work to the extent that my wife and myself and our daughter had to leave for a couple nights. So I am finishing this lecture from the lovely business center of a hotel in downtown Decatur. Such is life. And so we're just going to move forward and hope that no one else comes into the business center to join the lecture. You'll be able to see people exiting the elevator right about here. And so we'll just see if we get a surprise visitor or not. But anyway, let's move on. We left off from part one with this practice problem. You were supposed to take these data and make your own frequency table with a frequency, cumulative frequency, and cumulative percentage columns. So if we remember, these data are teacher ratings of high school seniors, such that 1 equals a rating of poor and 10 equals a rating of amazing. So the first thing we want to do is just get our table set up. So in our leftmost column, we again want all of our possible scores, not the scores that exist, but all of the possible scores that could exist. So in this case, they are 10 to 1. Remember, we want to start at the high end and move to the low end at the bottom of the table. So these are our possible scores. Our next column will be our frequency column, where we simply count up how many times each score occurs in the data set. Next will be our cumulative frequency column, and then our cumulative percent column. So we're going to go through step by step, checking our answers on each of these columns. If at any point you feel like you need more time to check your answers, just press pause, and you can take as long as you need, and then hit play to continue. So here we go. These are the frequencies. There was 1 score of 10, 2 scores of 9, 5 scores of 8, 4 scores of 7, so on and so forth. Take a second, check your answers, because if you don't have this right, then nothing else is going to be correct. Okay, so we've got that. That's pretty straightforward. And let's move on to cumulative frequency. What we want to do with cumulative frequency is count up the number of responses, or the number of data points at or below each score in our table. Here's what it looks like. Again, if you want to just check your answers real quick, press pause, and then press play for me to sort of walk through the logic here. So we end up with a score of 0, a cumulative frequency of 0 for the rating or score of 1, because there were 0 students rated as a 1, and 1 is our lowest score, so there's nothing below it. So there is 0 frequency, right? There are 0 scores in this data set at or below 1. So we move up to the rating of 2, the score of 2. There's 1, 2, and then we have to go, well, how many scores are below it? Well, there were 0 scores below it, so the cumulative frequency of 2 is 1, because there's 1 score at or below a score of 2. We move up to the score of 3. 3 students were rated as a 3, plus 1 student who was rated as a 2, plus 0 students who are rated as a 1. So 3 plus 1 plus 0 is 4. So this number tells us that there were 4 students rated at a 3 or below. We move up the table to the score 4. There were 5 students rated as a 4. We want to know how many students were rated as a 4 or below. So we go 5 plus 3 plus 1 plus 0, which tells me there were 9 students who were rated as a 4 or below. If you've got this down and you want a little quick shortcut, You can always just add this frequency to the previous score's cumulative frequency, right? You can add that direction and it will always work out, right? So 5 4s plus 4 people below it equals 9. 5 5s plus 9 people below it equals 14. 4 6s plus 14 people below it equals 18, right? So you can check your answers moving up. We had 30 total students who were rated. Okay. Now, for our last column, we will look at cumulative percentage, or what percentage of the data exist at or below each of these scores. So we will employ this little formula we learned in the first half of the lecture, and we're going to use this formula for each row, right? For each score. So we're going to use this formula for every single cell in this column. Here are the numbers if you want to take a quick look and check your answers. Oh, I thought I fixed that. Hold on. Bear with me really quickly. You're going to see behind the curtain these. Oh, goodness. These should have been 3s. Don't know why they were 4s. Okay, and we're back. Sorry about that. So here are all the cumulative percentages. Go ahead and check your answers. And then I'll go through and I will I'll give some examples moving up the table about the calculations. So go ahead and take a second and then press play when you're ready to move on. Okay, so let's take these one by one for a few at the bottom to give us an idea about how we do this. Remember, we're just going to use this formula for each of our cells. So cumulative frequency, so we're going to pull this number, right? The cumulative frequency of the score 1, that was 0, divided by n, which is our number of participants, right? Or in this case, our number of data points. There were 30 total students who were rated, 30 total data points. So 0 divided by 30 is, of course, going to be 0. And we multiply that by 100 to move the decimal point twice, and we get 0%. So what this number means is that 0% of the data are a score of 1 or below. That makes sense because there is no data at 1 or below. Those scores did not exist in our data set, so they represent 0% of our data set. We move up to the next row. We want to know what percentage of participants score a 2 or below. Well, there's only one participant that scores a 2 or below, right? We get that from our cumulative frequency column. There's only one score of 2 or below. So 1 divided by the total number of scores, which is 30, times 100, move the decimal point twice. That's what this 100 does again. And we get 3.33 repeating. Remember, we want to round to 2 decimal points in this class. So we'll just cut it off at 3.33. What this means is that 3.33% of the data represent a score of 2 or below. Next, we want to know what percentage of the data is a score of 3 or below. So we take its cumulative frequency, which is 4, right? Remember, there are 4 people who scored a 3 or below. 3, 1 plus 0. So 4 divided by 30 times 100 gives me a cumulative percentage of 13.33%. This tells me that 13.33% of participants scored a 3 or below. And so we can do this. We do this in turn for each of our scores until we have a completed table. It should always end at 100%, right? Because that last calculation is 30 divided by 30, which is 1, times 100, which is 100. So you should always end at 100%. If you do not end on exactly 100%, you have done something wrong. Okay, remember to round everything to 2 decimal points. So who cares, right? Why do we give a shit about cumulative percentage? I think as we explained in part 1, this is really important for decision making. I think the most salient, the most applicable place for this is something like college admissions. Or let's say in this case, the high school is going to offer scholarships for everyone in the top 10%. So everyone in the top 10% gets a scholarship. And these ratings, these teacher ratings, are what they use to give the scholarships. And so we could answer this question, right? How many people get the scholarship? And if we knew them, we could give the scholarship to those particular people. And so a lot of places will use this sort of metric, this cumulative percentage, as a way to dictate decision making about things like scholarships or raises if you're in the workforce, or college admissions, or things of that nature. It's really really useful if you have a limited pool of money and you want to give that money or that commodity to the top 5% or the top 30% or the top 40%. This is essentially what you do. Okay, so take a second, think about it. I'm not going to tell you how to do this yet, but think about it and see if you can answer this question. We want to give a scholarship to the top 10% of these students. How many people get the scholarship? So press pause, think about it, and press play when you're ready to come back for the answer. Three people. When you think about it, that makes sense, right? There's 30 people. We want to give it to the top 10%, so that's 3. But let's use our table, right, to make that decision. So if we look at the cumulative percentage, what we're looking for is the place on the table that divides the top 10% from the bottom 90%, right? The top 10% from the bottom 90%. That place on the table is the distinction between a score of 8 and 9. Notice how that if you scored an 8, then 90% of the people are at or below you, right? You are essentially in the 90th percentile. So if you scored an 8, that's the point where 90% of people are at or below you. So if 90% of people are below you, then what percentage of people are above you? 10%, right? So this marker between a score of 8 and 9 is the line, is the divide between the top 10% and the bottom 90%. Now, a lot of you probably said, well, a rating of 8, right, includes that because we have this 90, it says 90%, right? So they're in the top 10%, but they're not. They represent the place, the divide of the top 10% from the bottom 90%. And if you're in the bottom 90%, which they are, right? If you scored an 8, you are at the place where 90% of the data is at or below you. If you are in that group, then you are not in the top 10%. You're in the bottom 90%. The people above you are in the top 10%. And that's people who score a 9 or a 10. And there are 3 of them. And 3 is 10% of 30. So it makes perfect sense. So this is just an example of how this type of frequency data can be used to make decisions. Right? So 90% of the data fall at or below a rating of 10. Thus, 10% of the data are above that in a rating of 9 or 10. So we could ask questions like, we want to take the bottom 30% and we want to get them some help, right? Some tutoring or whatever, right? They need to go talk to the counselor about any issues they're having, right? So we can use this cumulative percentage to also identify maybe people who need help, people who need assistance on the bottom end. So if we want to find the bottom 30% of the data, that's a little easier. We just look for 30% in our cumulative percentage table. And so that's the point where we find the bottom 30%, because If you scored a rating of 4 or below, then you are at the place where there are 30% of the data at or below you. That means you're in the bottom 30%. Okay. So we're going to move forward with 2 new ways to visualize data. The first is called a frequency histogram. This is just basically taking a frequency table. Sorry, I was just about to point with my fingers if you could see it. It's basically just taking a frequency table like we've created before and like turning it on its side and making it into a bar graph, essentially. That's the best way to explain it. So we have here our scores. You'll often see that denoted as our X's, right? The possible scores. You could score a 5, a 4, a 3, a 2, a 1. You have our F's, so our frequencies of those scores. So 2 people scored a 5, 3 people scored a 4, 4 people scored a 3, so on and so forth. And so what we can do is we can turn these frequencies into the height of a bar such that the taller the bar, the greater the frequency of that particular score. So to do this, we take our X's, our possible scores, and we lie it on its side, and we turn it into the x-axis of our graph. So this is a score of 1, a score of 2, a score of 3, a score of 4, a score of 5. Our y-axis represents the frequencies of each score. So we see here we have a score of 1. That occurred one time, right? A score of 1 occurred one time. And so it has a bar height of 1. The score of 2 occurred twice. So it has a bar height of 2. A score of 3 occurred 4 times. Score of 3 occurred 4 times, right? So its bar is up here on the y-axis to a 4. And then 3 people scored a 4, 2 people scored a 5. So you just take the frequency table, flop it on its side, make the scores the x-axis, and you make the frequencies the y-axis. That's about it. Convention here is not to have spaces between your bars. You just kind of let the bars run into each other like that. It just kind of makes it cleaner to look at, and it allows you to sort of see this distribution of scores a little more easily. Because what we can see here is that the most common scores were like in the middle, around a 3. We have slightly more people on the high end than the low end, right? So if these are quiz scores, so like on average, if I was a professor who got these quiz scores, I'd be very happy, right? We have most people scoring a 3, 4, or 5. 3 sort of is average, and then there are more 4s and 5s than there are 1s and 2s. Right? So the class did pretty well. We can sort of smooth out these. I'm sorry, I don't think these are called histograms, right? That's sort of how we refer to them. Technically, they're called frequency histograms. Most of the time, you'll just see people calling them histograms. The thing to remember is that the height of the bars doesn't reflect a score on the quiz. The height of the bar is the frequency of the score. It's just another way of looking at how often a score occurs. We call these, when we sort of flatten these out and make them into this smooth sort of curve, we call these distributions. So we can take a frequency histogram like this. This is how much did you enjoy your psych courses, right? 0 to 5. We see here on the y-axis frequency. So lots of people enjoyed it, rated as a 4 or 5. Very few people responded on the low end. And you can use like computer programs. We're not going to get into that this semester. But basically they draw, for lack of a better term, like a line of best fit. That's not exactly what it is. But it's basically just sort of smoothing this out into a distribution. Finding sort of a pattern in the distribution, if you will. And there are a few ways that we describe these distributions. This distribution is what we call negatively skewed, meaning that there are lots of data on the high end of the measure and very little data on the low end. So we call it negative skew because these lower values, the ones approaching the negative end, are skewing the data, right? This person that responded as a 0, they're the weirdo, right? Like they're the outlier. They are different from everyone else, right? This person just was angry at the professor, right? For some reason, right? Clearly, these courses were excellent because the vast majority of people rated them as a 4 or a 5. This person over here is just wonky, right? They're this weird data point. We don't know why they're over there, but they are, and they look very different from everyone else. And so what they're doing is negatively skewing the data. They're sort of having an adverse effect on the data, if you will, by being very different from everyone. Right? They're outlying from the data for some reason. So when the data accumulate at the high end, and we have this tail on the negative end, we call it negative skew. And so, of course, the same is true in the flip side. When the data accumulate at the low end of the scale, right, there is greater frequency of data at the low end. This is age, right? So maybe this is like age of college students at Georgia State or something, right? We have a lot of people who are 20 to 25 or whatever, and then as you increase in age, there are fewer and fewer students. That's plausible. So we would call this a positive skew because these people over here at the high end of age are the ones sort of pulling the distribution. They are the sort of outliers, the less common scores. And so we can reflect the sort of general trend of the frequency of data with this curve. The height of the curve, again, tells us just what the height of the bars do, the frequency of the data. So we can see the bulk of the data are here on the low end, and then there's very little data over here on the high end. And so this tail, right, is pulling the data, and so it has a positive skew. So just remember, when we describe these distributions, if the data collect at the bottom, it's a positive skew. We name skew by the tail of the distribution, not the body or the bulk of the distribution. So if the tail is at the high end, then it's a positive skew. If the tail is at the low end, it's a negative skew. We need to know this now for some things that we're going to encounter in the future. So just kind of, roll this around in your head and get used to the idea of describing groups of data in this way. Okay, so let's practice a histogram. I want you to take these data. I want you to make a frequency table. So list all of your possible scores. We'll say that the possible scores here are 10 to 15. No, I'm sorry, they go up to 17. The possible scores here are 10 to 17. So what I want you to do is make your frequency table starting at 17 down to 10, and then count up the frequencies of each score, and then turn that into a histogram, one of these graphs for me. So go ahead and press pause. Our possible values here are 10 to 17. So take a crack at this, and then when you're ready, press play, and we'll see the correct answer. Okay, so, sorry, my 16 is a little wonky over here. Here's more or less what your frequency histogram should look like. We had one score each of 10, 11, and 12. We had 4 scores of 13. We had 6 scores of 14. We had 4 scores of 15. We had 0 scores of 16, so it has no bar. And then we had 1 score of 17. So this is roughly what your histogram should look like. Again, remember your possible scores are on the x-axis, and the frequency of those scores is on the y-axis. Lastly, the last way that we can visualize data is a stem and leaf plot. I'm going to be really honest with you. Nobody does this in the sciences. I mean, maybe there's like some people out there that for some reason, this is valuable for them. It is a perfectly legitimate way to visualize frequency of data. You could see it, but you don't see it very often. But we do need to go over it just in case it occurs. This is a way of visualizing data in chunks, right, or specific numerical categories. So what we're looking at here is a stem and leaf plot of data for age. And age is not a bad variable to use for a stem and leaf plot, particularly if we're interested in looking at data by decade, right, by decade of age. And that's what you do with a stem and leaf plot. You choose some sort of categorization, some chunk, like a decade or a century or something like that. And then you cluster data based on their membership in one of those categories. So how do you read a stem and leaf plot? What do you do? We have on the left side our stems. This is age. So our stems are essentially the decades. So a stem of 0 would mean a single digit age, right? From 1 to 9. If something has a stem of 1, that means we're in the tens decade. So an age of 10, 11, 12, 13, all the way up to 19, right? Where the first number is a 1, right? It's the stem, the start of the number is a 1. And so if you score anything with a 1, 0, a 1, 1, a 1, 2, a 1, 3, then you're going to go into this leaf of this stem. This 2 represents the 20s decade, 30s decade, 40s decade, so on and so forth. You have leaves, and each number in a leaf section represents an individual data point. So this 1, right, we read this 1 by saying a stem of 0 and a leaf of 1. So that's a 0 and a 1. So this person is 1 year old. 1 year old. Then we move on to the next one, a 0 and a 1 again. So we have another person that's 1 year old. So we have 2 people that are 0, 1 years old. Then we have 2 people that are 0, 2 years old. We have 1 person who is 0, 3 years old. We have 4 people who are 0, 4 years old, so on and so forth. So here we have a 1 year old, a 1 year old, a 2 year old, a 2 year old, a 3 year old, a 4 year old, a 4 year old, a 4 year old, a 4 year old, a 5 year old, and an 8 year old. And so you repeat the leaf. So you can have the same leaf multiple times. That just means there's multiple people with that score, or in this case, with that age. So if we move down to other decades, then here we have a 1. So now all of the numbers in this leaf section are going to start with a 1. So this 0 doesn't mean 0 years old. It means 10 years old. This 0 doesn't mean 0. It means 10 years old. This 1 means 11 years old. This 1 means 11 years old. This 3 means 13 years old. This means 17. This means 19. So we had 3 10-year-olds, 2 11-year-olds, 1 13-year-old, 1 17-year-old, and 1 19-year-old. Now we'll do the 20s decade just to make sure we've got it down. This 5 means we have a 25-year-old. This 5 means we have another 25-year-old. The 7 means we have a 27-year-old, so on and so forth, right? 2 25-year-olds, 2 27-year-olds, 2 28-year-olds, and 2 29-year-olds. And so you can read that all the way down. That's how you read a stem and leaf plot. If you're creating one, right, let's say these were your data, right? You create your stems based on, in this case, your decades, right? Your teens, your 20s, your 30s, your 40s. And then this 32, right? It has a stem of 3 and then it has a leaf of 2. And so you just sort of transpose the data down into the plot. Again, not super common in the sciences. It is a way to visualize data. I suppose there are some situations where you might want to use it, but you're much more likely to see one of these histograms in modern science. Much more likely to see one of these than you will ever see a stem and leaf plot. Okay. So that's where we're going to end. There will be practice problems uploaded on iCollege for you in this module. There will be answers uploaded with them. So this is independent of any sort of workshop or quiz or anything like that. You're going to have a reading quiz as well as a workshop where you're going to have to do some questions on this or practice and then turn in an answer for credit. But then I'm also going to give you additional practice sets with the answers. So use those practice sets to test yourself and then legitimately do it without looking at the answers, and then look up the answers to see how well you've done. So for your workshop for this section, I want you to create a frequency table with frequency, cumulative frequency, and cumulative percentage for these data that you see above you. So what I want you to do is imagine that we ask a group of 20 people, how many siblings do you have? And then here's the data that they provide us, right? Each number represents a single individual, and the numbers represent how many siblings they have. So I want you to take these data and create a frequency table that has a frequency column, a cumulative frequency column, and a cumulative percentage column. Then I want you to draw a frequency histogram to also visually represent these data. And then I want you to upload it to iCollege in the workshop assignment. So if you can do this like in an Excel file, I'm fine with that. That's cool. If you do this in Word, that's fine. If you do it on physical paper, just take a picture of it and upload the image to the iCollege workshop assignment. So whatever you have to do to get this uploaded to iCollege, that's fine with me. It can be an Excel file, it can be a Word file, it can be a JPEG or a PDF. Doesn't matter what it is. Just do this, practice this, and upload it to iCollege by the due date. Again, in addition to this workshop, there will be another set of practice problems with answers for you to work on, but that's just for you to help yourself out. You're not going to turn any of that in. So make sure you get this done. This is your workshop for this section, and upload it to iCollege. So thanks, everyone. I appreciate your, patience with all of the people back here coming out of the elevator, and I hope it wasn't too distracting. I will see you next time. Thanks.